Can you give me some examples of the experiments that you would want to fly in space?
Well, last year we cooperated with NASA and Make Magazine in what we called the NASA Make Challenge. The winners of the challenge turned out to be two NASA engineers from JSC who proposed an innovative microgravity kit. It's called the Bring It Back kit. This is a very low-cost kit which can be built by teachers, by home hobbyists, by citizen scientists. It can be built for probably around $100, perhaps a little bit more. It's a way of capturing the microgravity environment in solid form and bringing it back to Earth. The way this is done is by flying a small container of wax, which is heated during the ascent stage and then allowed to re-solidify in microgravity. In the process, you can capture the structure of the microgravity environment. You can capture things like bubbles, convection flow within the wax. And then you can bring it back to Earth and you can slice it, create thin sections, put them under a microscope, study them in various ways. This is a tremendously creative experiment concept. It's a kit which can be used to do any number of possible experiments. Not only does this win the NASA Make Challenge, but afterwards it actually won a Technology Innovation Award from the National Laboratories Consortium. So this is the sort of experiment that we look forward to flying on these new flights on the X-Square Lynx, along with a lot of other very innovative experiments which we hope that people will propose to us. Down the road, we're looking at things like the Absa Telescope. This is a suborbital space telescope which is being developed by professional astronomers to fly on the Lynx. This will be a ways down the road. It's actually scheduled to fly on the Lynx Mark III. It's being developed by Dr. Faith Vila, who used to be the director of the Multi-Mirror Telescope Observatory in Arizona. She recently retired from that position to develop this new suborbital observatory to fly on the Lynx. But the intent behind the Absa Space Telescope is to make this available to astronomers from all over the world. So I asked Dr. Vila, does this include amateur astronomers? And she hesitated for a moment because she hadn't thought about this question before, but her response was, I don't see why not. You know, amateur astronomers have contributed greatly to the development of astronomy in many fields, especially discovering new comets, asteroids. So there's a potential that one of our payload operators, a citizen scientist, might some years down the road do an experiment in conjunction with the Absa telescope on the Lynx. Or perhaps we'll even have someone develop an amateur space telescope to fly on the Lynx today. You know, the great thing about the Absa Space Telescope, you look at the hardware, the telescope itself is based on a 14-inch Celestron telescope, which is commercial off the shelf. The imaging system is an infrared camera, commercial off the shelf. Really, the only custom hardware component is the gimbal drive assembly, which they're now in the process of building a prototype for at the Citadel, one of their partner universities. But the prototype drive assembly is being built by a team of 3 undergraduate students. This is something which could be done on an amateur level. So there are all these unique possibilities that are being opened up for future research. Now, again, we're not going to be flying amateur space telescopes on the Lynx in our initial campaign. The experiments that we're looking for right now will fly in the crew cabin, in the payload box behind the pilot seat, or they will fly in the 2 aft cowling ports, which can accommodate double cube-sized experiments, double CubeSat-sized experiments, optionally ejectable, You'll have access to the space environment. You can expose your payload to vacuum. You can eject the payload if necessary, include some sort of recovery system, a parachute to bring it back to Earth. There are all sorts of possibilities that citizen scientists can work on. And I think that this is going to get a tremendous response from the hobbyist community. If you look at the whole maker community and the way it's developed in recent years, you now have 120, 150,000 people showing up at Maker Faire every year. These are people who have interest in every type of applied science and engineering. And if we just tap into this field and combine the enthusiasm of the maker community with the new capabilities that are developing in the NewSpace area, we can create a revolution in what's possible in citizen science. You know, today, citizen science has evolved to a level which no one ever thought it would a few years ago. You have citizen scientists who are discovering new planets around other stars, who are finding new dinosaur species, who are helping to map the human genome. You have websites like Zooniverse, which allow citizen scientists to go online and work with professional data from the Hubble telescope, from the NASA Kepler mission, from space probes. And we think that the new reusable suborbital vehicles that are now being developed will be the next great enabler for citizen science.